Hello viewers, my name is Dr. Kishan Ajay Kumar, Associate Professor from Institute of Aeronautical Engineering, Department of ECE, Hyderabad. So today we are going to discuss the topic, the measurement of gain and directivity, which is related to the course Antennas, Waves and Propagation. So today's topic is the measurement of gain and directivity, which is related to the course Antennas, Waves and Propagation. Let us start our session. So whenever we draw the radiation pattern, we are going to measure some parameters from the radiation pattern. So those parameters are the radiation pattern measurement, the gain measurement, the directivity measurement, and there are many other parameters like half power beam width, antenna gain, antenna efficiency, and FBR, that is the front to back ratio. So there are different types of parameters for an antenna which will decide the performance of the antenna. So out of these parameters, we are going to see what is the setup required for measuring these parameters. So what is the basic setup required for measuring these parameters? That is, let us see these three concepts today. That is the radiation pattern measurement setup, the directivity measurement and the gain measurement, and what are the methods or approach followed to measure these parameters. The first one is the radiation pattern measurement. So there are two types of procedures for us to determine the radiation pattern measurement. So in the first procedure, the antenna under test, that is the primary antenna, is kept stationary, while the secondary antenna is moved around the primary antenna along a circular path with uniform radius. If the secondary antenna, it is a directional one, it is always aimed at the primary antenna. Let us say, suppose there is an antenna here. This is the first case, in the case 1. Here, there is an antenna. This antenna, we call it as the antenna under test, AUT, antenna under test, which is also known as the primary antenna. It is stationary. We are not going to move this antenna. And around this antenna, we draw an observation circle. And on that observation circle, let us place another antenna, which is known as the secondary antenna. This is known as the secondary antenna. This is secondary. And this is the primary antenna. We need to keep the primary antenna fixed. And at the same time, the secondary antenna must be movable along the observation circle. That means here the secondary antenna is moved around this primary antenna, either in the clockwise direction or in the anti-clockwise direction. So the secondary antenna is moved around the primary antenna along a circular path with uniform radius. So this is known as the uniform radius. Now if the secondary antenna is a directional one, the secondary antenna is directed directly towards the primary antenna such that the field strength that is absorbed by the secondary antenna must be maximum. The secondary antenna is aimed at the primary antenna in such a way that the field strength that is measured on the observation circle must be maximum. So in this procedure, usually the primary antenna is transmitting, the secondary antenna is receiving. The secondary antenna is the receiver here, the primary antenna is the transmitting antenna. So the transmitting antenna is sending the signal here, the receiving antenna is receiving the signal. So when the receiving antenna receives the signal, we need to record all the field strength that is measured on the observation point. Let us say, for example, here, if this is the transmitting antenna, AUT, and over this observation circle, let us indicate in the receiving antenna, or the secondary antenna. So at this point, we need to measure the field strength. What is the amount of field strength from the transmitting antenna? Let us say the field strength, it is 5 volts per meter. And again, the receiving antenna is moved on the observation point. At this point, let us measure the field strength at this point as we are getting as 4 volts per meter. It means that on the different points on the observation circle, we need to find out the field strength. How much amount of field strength? Suppose let us say at this point we are getting 3 volts. So what we need to do is the field strength after recording all the points on the observation circle. So based upon the different points, based upon the recordings that we have observed, we need to draw the radiation pattern. We need to draw the radiation pattern where the field strength is maximum and also uniform. So where the field strength is maximum and where the field strength is uniform, we need to draw the radiation pattern based upon the recordings that we have been noted. So this is the first procedure to draw the radiation pattern measurement. So at different points along the circular path, the readings of the field strength and the direction with respect to the primary antenna are recorded. So after recording all the plots, we need to draw the radiation pattern. In the second procedure, both the antennas are kept stationary with a suitable spacing between them. The secondary antenna is aimed at the primary antenna. The primary antenna is rotated about a vertical axis. The secondary antenna is aimed at the primary antenna. The primary antenna is rotated about the vertical axis. So in this procedure, the secondary antenna is used in the transmitting mode so that the field strength reading and the direction of the primary antenna with respect to the secondary antenna is made. So let us say, suppose here, in the second case, that is in the second case 2, or the second procedure. In the second procedure, what we need to do is, we are going to place a receiving antenna exactly at the center, and here on the observation circle, these antennas, another antenna, this is the receiving antenna, and this is the transmitting antenna, and this transmitting antenna is placed on the observation circle. And see that these both antennas, that is the transmitting antenna and the receiving antenna, are stationary. They are not movable. They are fixed at certain points. So when the transmitting antenna is sending the signal, by means of a rotator, we need to rotate the antenna. We need to rotate the antenna in clockwise direction. We need to rotate the antenna in clockwise direction only. See that the antenna, the receiving antenna is fixed and it is stationary. Only the antenna is rotating. Only the antenna is rotating. So when the antenna is rotating, so we need to record all the field strength that is been observed by the receiving antenna. So the transmitting antenna is aimed towards the receiving antenna. The transmitting antenna signal is aimed and directed towards receiving antenna, but the receiving antenna is rotating in clockwise direction. So when the receiving antenna is rotating in the clockwise direction, so we need to record all the field strength points, all the electric field strength points. So after recording all the field strength points, based upon the points, we need to find out at which direction the field strength is maximum, at which direction the field strength is minimum, and in which direction the electric field strength is uniform. So in whichever the direction the electric field strength is maximum and uniform, all those points are considered to draw the radiation pattern. So the readings at different points are noted by means of a pattern recorder. You can see here there is a pattern recorder. This pattern recorder is attached. This pattern recorder is attached to the receiving antenna. This pattern recorder is attached to the receiving antenna. This pattern recorder will record all the field strength points when the antenna is being rotated in clockwise direction or anti-clockwise direction with respect to the transmitting antenna. So generally at low frequency, the first procedure is used, and at high frequency, the second one is preferred. So generally at low frequency, the first procedure is used, while at high frequency, the second procedure is preferred. So this is the first parameter, and this is the setup required for measuring the radiation pattern. So here basically what we need to measure, what is the setup required to draw the radiation pattern here. So we need two different types of antennas, and we need a pattern recorder to record the readings of electric field strength. So this is the basic setup required for drawing the radiation pattern or for the measurement of radiation pattern. And you can see here the radiation pattern measurement. So this is the basic setup here. There is a transmitter here, and here there is an indicator, and there is a mechanism here, antenna rotator mechanism, and here there is a receiver. Here in the first case, the primary antenna is sending the signal, and the secondary antenna is aimed towards the primary antenna, and there is an antenna rotator mechanism. We can rotate the antenna either in the clockwise direction or in the anti-clockwise direction. whenever the antenna is rotating by means of the rotator mechanism, there is an indicator here. The field strength is calculated, the field strength is recorded by this indicator. So this is the basic setup required for drawing the radiation pattern measurement. So basically a transmitter, an RF cable is required for connecting the primary antenna. An antenna rotator is used for rotating the antenna in the clockwise direction or in the anti-clockwise direction. And for this antenna rotator, there is a support shaft for antenna. That means the antenna is fixed to this rotator by means of a support which is known as a shaft. The next parameter which we are going to measure is gain. So gain is calculated, the gain of an amplifier is different from the gain of an antenna. Why? Because whenever we are going to measure the gain of an amplifier, just we calculate the output by input. That means the output voltage to the input voltage or the output current to the input current, we are going to calculate the gain of an antenna. Similarly, the gain of an antenna is measured by taking two antennas into consideration. That means it may be one may be the reference antenna, one may be the practical antenna. So whenever we are going to measure the gain of an antenna, we are going to consider the two different types of antennas. So one is an isotopic, it may be an isotopic antenna or a reference antenna, and another may be the antenna under test or the practical antenna. So in order to measure the gain, we are having two methods. One is absolute method, the other one is the direct comparison method. One is the absolute method, the other one is the direct comparison method. So first we will see the absolute method. In absolute method, again we are having two methods. One is a two antenna method, the other one is a three antenna method. So here the gain is measured in two methods. One is absolute method and the direct comparison method. Again, the absolute method, there are again two methods we are having to find out the gain. One is by two antenna method, the other one is three antenna method. Let us see the absolute gain method first. So the measurement of absolute gain by two antenna method. Here we are having a setup required for measuring the gain. In two antenna method, we are using only two different types of antennas. So one is the transmitting antenna, the other one is the receiving antenna. Let us assume the receiving antenna is the antenna under test. Let us assume the receiving antenna is the antenna under test. So here there is a power bridge. This is in the transmitting antenna section. We are having a power bridge, a modulator, a signal source, and a calibrated variable attenuator. That means here the power bridge is nothing but the amount of power that is given to the input transmit. The power bridge is nothing but the amount of input power that has to be given to for the transmitting antenna. And again, whenever we are going to transmit the signal has to be modulated. That means we need to apply some frequency, we need to give some input voltage, and we need to apply some method like amplitude modulation or frequency modulation or amplitude shift keying or frequency shift keying. So any type of a modulation we can carry out with the signal. So after the signal is being modulated, after the signal getting modulated, this modulated signal is given as input to the attenuator. Is given as an input to the attenuator. So whatever the amount of signal we want to give to the transmitting antenna, that much amount of input signal can be given to the transmitting antenna by means of an variable attenuator. Suppose here the power bridge is given the input as 20 watts. Suppose the input power bridge, the input power that is given as an input is 20 watts. Now I want to transmit the signal, only the 10 watts of signal is given as input to the transmitting antenna. The 20 watts power bridge, the signal, the total capacity is 20 watts, but I want to give the input signal as only the 10 watts for the transmitting antenna. So we can use here the calibrated variable attenuator. Here there is an attenuator where how much amount of input signal has to be given, that much amount of signal can be varied by the calibrated variable attenuator. And here the transmitting antenna is placed with respect to the receiving antenna, and we need to place the receiving antenna in such a way that maximum amount of strength is absorbed, or the maximum amount of radiation is captured by the receiving antenna, that is the antenna under test. Both must be in the same line of sight. You can see here the transmitting antenna and the receiving antenna both must be in the same line of sight. That means both must be same axis. The alignment must be same in such a way that maximum amount of energy is captured by the receiving antenna from the transmitting antenna. And here there is an indicator which records all the energy that is being captured by the receiving antenna. Here there is it may be indicator, it may be a pattern recorder, or it may be a electric field strength calculator. So the amount of electric field strength observed by the receiving antenna is recorded in the indicator. So here what we know here is, we already know what is the amount of signal being given to the transmitting antenna. It is a known parameter. So what is the amount of signal that is being given to the transmitting antenna? It is a known parameter. And what is the amount of electric field strength received by the receiving antenna? It is an unknown parameter. So we need to find out the unknown parameter from this indication, from the indicator. So here, from Fritz's transmission formula, we know that there is a relationship between the amount of power received and the amount of power transmitted. So the amount of power received PR is equal to PT GT GR into lambda by 4 pi R whole square. Lambda by 4 pi R whole square, it represents the free space loss factor. So lambda by 4 pi R whole square, it represents the free space loss factor. So the amount of power received PR by PT is equal to GT GR into lambda by 4 pi R whole square. Here the PR represents the amount of power received. PT represents the amount of power transmitted. So we know this is the known parameter. And the gains of the transmitting antenna and the gain of the receiving antenna are already known to us. GT and GR are also PT, GT and GR are, these three are the known parameters, or the predefined values. And R, capital R, represents the distance, total distance between the transmitting antenna and the receiving antenna. R, capital R, represents the distance between the transmitting antenna and the receiving antenna. Let us take the logarithmic, apply the log function on both sides. If we apply the logarithmic function on both sides, we will get log PR by PT is equal to log GT plus log GR plus log lambda by 4 pi R whole square. So if we want to convert this into dB, we want to represent this in terms of dB, we can multiply on both sides by 10. So multiplying both sides by 10, you will get 10 PR by PT is equal to 10 log GT plus 10 log GR plus 20 log lambda by 4 pi whole square. So if 2 into 10, if you multiply with 10 here, 2 into 10 is equal to 20. 2 into 10 is equal to 20, you will get 20 log lambda by 4 pi R whole square. So based on the Fritz's transmission formula, we are going to find out the amount of power received. See here, if we calculate 10 log PR by PT and we are going to calculate the gain. So let us add up these two equations and bring this equation to the right hand side. As we are going to calculate the gain, so let us bring this 10 log GT plus 10 log GR to the left hand side and 10 log PR by PT to the right hand side. So you can interchange these equations. If we assume the gains of the transmitting antenna and the gain of the receiving antenna are similar, under this condition, let us assume as GT is equal to GR is equal to G. The gain of the transmitting antenna, the gain of the receiving antenna are same. Under this condition, GT plus GR can be replaced by G. So G plus G is equal to 2G. So G plus G can be written as 2G. So 2G is equal to, you will get 10 log PR by PT plus 20 log 4 by R by lambda. So overall, if you calculate the value of G, you will get half into 10 log PR by PT plus 20 log 4 by R by lambda. 20 log 4 by R by lambda. So this is how to calculate the absolute gain by two antenna method. That means the gain by absolute method can be calculated by using this formula. That is G is equal to half into 10 log PR by PT plus 20 log 4 pi R by lambda. So here from this formula what we can study here is R is the known parameter, the distance. Lambda, it depends upon the operating frequency we give to the transmitting antenna, how much amount of frequency we are applying for the transmitting antenna, and how much amount of power is given, how much amount of power, PT represents how much amount of power is given to the transmitting antenna, and PR, the value power, amount of power received, we need to record from the secondary antenna, that is the receiving antenna. So PR antenna has to be noted down. PR and PR, that is the amount of power received. We need to, from the based upon the indicator, the electric field strength, how much amount of power is received, we need to record the reading, and that reading has to be substituted in this formula, that is the PR value. So if we simplify this value, if we simplify this equation based upon the known parameters and the unknown parameter PR, we will get the absolute gain. We will get the absolute gain. So this is known as the two antenna method to measure the absolute gain by two antenna method. If you want to measure the absolute gain by three antenna method, so this is the setup required, the gain measurement by absolute method or three antenna method. So gain measurement by absolute method or three antenna method. So here what we are going to do is, we are going to use three different types of antennas. One is antenna 1, one is antenna 2, one is antenna 3. So that same setup as we have seen earlier, the same setup is required, except the only difference is an extra antenna is used. Here antenna 2, it is known as a standard antenna or a reference antenna. It is also known as a standard gain antenna. Antenna 2 is known as a standard antenna or a standard gain antenna. So what is the difference between an antenna and a standard gain antenna? The standard antenna is one whose parameters already we know. A standard antenna, gain antenna is one whose parameters are already new. That means we know the gain of the standard gain antenna, and we know the half power beamwidth of the standard gain antenna, and we know the transmitting the input power of the power of the standard gain antenna. So all the parameters, whatever we have defined, all those parameters are predefined for a standard gain antenna. Now here let us start the experiment here. So to determine the gain by absolute three antenna method, so here what we are going to do is, here there is a power bridge here there is a power bridge. The first case we combine the G1 and G2. In the second case we are going to combine G1 and G3. And in the third case, we are going to combine G2 and G3. That means the gains. So here, G1, G2 and G3 represent the gains of the transmitting antenna. 1, G2 represents the gain of antenna 2, G3 represents the gain of antenna 3. Now let us combine first the two antennas. The first case, this is the first case, G1 and G2. So in the first case, if we combine antenna 1 to the antenna 2, here you can see in this setup there is a switch here. This switch is used to connect either antenna 2 or antenna 3. Switch is used to connect antenna 2 or antenna 3. And antenna 1 here, you can see here, this antenna 1 is aimed towards the antenna 2. This is the antenna 2. Here the antenna 1 acts like a transmitting antenna, and antenna 2 acts like a receiving antenna here. So we are giving some input power here, and the signal is being modulated here by some AM or FM technique. Amplitude modulator or frequency modulation is done here. And whatever the amount of input signal that has to be given, it has to be given to the transmitting antenna by means of a variable attenuator. Here the total input power is 20 watts. If you want to give only the 10 watts, here there is a calibrated variable attenuator, it will attenuate the signal. So whatever the amount of signal that has to be given, that will be given by the variable attenuator to the transmitting antenna. So overall, a modulated signal is being applied to the transmitting antenna, that is antenna 1, by means of an attenuator. Now this standard antenna is connected to the antenna 1. Now this standard antenna, that is antenna 2, is aimed towards antenna 1 to receive large amount of signal, and whatever the amount of power received by this antenna 2, that has to be noted. Whatever the amount of power that has been captured by the antenna 2, that has to be recorded by the antenna 2. Now after noting down, so what we are going to do here is, Now we shall combine G1 and G3. Here, the first case, antenna 1 and antenna 2 have been combined here. In the second case, combine 1 and 3. That means the switch is here, the switch is disconnected from antenna 2. Now the switch is connected to antenna number 3. Now again the experiment is repeated. The antenna 1 is transmitting the signal here. The antenna 3 acts like a receiver here. Antenna 3 acts like a receiver now. So when antenna 3 is acting like a receiver, how much amount of power is received by antenna 3, that record has to be noted while the antenna 1 is transmitting. So in the first case, what we did is 1 and 3 have been combined. In the second case, we have combined 1 and 2. And in the third case, we are going to combine 2 and 3. We are going to combine 2 and 3. That means G2 and G3. So here G2 acts like a transmitting antenna. It means that you remove this antenna for case 3. In the case 3, remove this antenna 1. You replace this antenna 2 here. Replace this antenna 2. Now here there is an antenna 2 here. Our antenna 2 is a transmitting antenna here. And antenna 3 is the receiving antenna here. So when the antenna 2 is transmitting the signal, antenna 3 is a receiver antenna. What is the amount of power received by this antenna 3? You note down the reading by means of this indicator. Right? So remove this antenna 3 here. This antenna 2 has to be replaced here. And you disconnect this antenna 1 here. Now standard gain antenna is the transmitting antenna. Antenna 3 is the receiving antenna. So in for these three cases, by joining antenna 1 and antenna 3, by joining antenna 1 and antenna 2, and by joining antenna 2 and antenna 3, we need to record whatever the amount of power received at the receiving signal. What is the amount of power received at the receiving antenna? So combining by use of the Frisch transmission formula above, explained the previous slide, we have seen G1 plus G2 is equal to 10 log PR by PT1 plus 10 log 4 pi r by lambda. See here, you can see here, this is antenna 1 and this is antenna 2. In the first case, what we did is 1 and 2 have been combined. 1 and 2 have been combined. The second antenna is standard gain antenna. So here we are going to denote the suffix G1 for the transmitting antenna 1, G2 as 2 represents the antenna 2. 2 represents the gain of antenna 2. And R2 represents the receiving antenna 2. PR2 represents the amount of power received at antenna 2. PT1 represents the power transmitted by the antenna 1. So this is the fixed one, 20 log 4 pi r by lambda. Why? Because R is the fixed distance between the antenna 1 and antenna 2. And lambda is the wavelength which depends upon the operating frequency. So this is case 1. Similarly, we are going to write the expressions based upon the first one when 1 and 3 have been combined. That means here the 1 is the transmitting antenna and 3 is the receiving antenna. So what is the amount of power received by this antenna is denoted as PR3. So when 1 and 3 have been combined, antenna 3 becomes the receiving antenna. As antenna 3 is the receiving antenna, the amount of power received by the antenna, we are going to denote it by symbol PR3. And PT1 is common, that is the power transmitted as PT1. And 20 log 4 pi r by lambda is also common, that is the fixed distance. R is fixed, that is the distance between the transmitting antenna and receiving antenna is fixed. And similarly, G2 plus G3 is equal to when second antenna and the third antenna have been combined, we can write the equations as G2 plus G3 is equal to 10 log PR3 by PT2 plus 20 log 4 pi r by lambda. So by combining these three antennas, 1 and 2 and 2 and 3 and 2 and 1 and 2 and 1 and 3 and 2 and 3, we are getting a total 3 equations. So by simplifying, there are 3 independent variables. See here G1, G2 and G3. So G1, G2 and G3 are 3 different variables. So we are having 3 different variables and we are having 3 different equations. So we can simplify by simple mathematics to determine the values of G1, G2 and G3. So we are having three different variables, G1, G2 and G3. So by simplifying these expressions, we can determine the values of either G1, G2 or G3, which we are call it as gain of the transmitting antenna 1, gain of the transmitting antenna 2 or gain of the transmitting antenna 3. So this is the absolute gain by 3 antenna method. Next we shall determine the measurement of gain by 3 antenna method by direct comparison method. By the direct comparison method. Here this is the figure for measurement of gain by direct comparison method. Here what we are going to do is, there are three different types of antennas. One is the primary antenna, the secondary antenna and the standard gain antenna. A standard gain antenna is one whose parameters are already known. Now let us start our experiment. In the first case, so what we are going to do is, the transmitting antenna is sending the signal here, and there is a power bridge here. This is given as the input power, giving as the input signal. The signal is being modulated here, and how much amount of signal has to be given. This is done by the variable attenuator here. It will attenuate the signal. It will reduce the strength of the signal, and whatever the input signal is given, that is being given to the transmitting antenna here by means of some cable here. And see here, there is a primary antenna here. The switch is connected to the primary antenna first here. The primary antenna is connected to the switch here. And what is the amount of power received when connected? Primary antenna is connected. That amount of power is noted by the indicator here. What is the amount of power? It is been recorded by the indicator. The distance between the transmitting antenna and receiving antenna must be equal to 2d square by lambda. So this is the condition for far field region. So only in the far field only the radiation pattern is clearly observed. Hence this condition has to be satisfied here. R is equal to 2d square by lambda. D represents the dimension of the antenna or the length of the antenna, and lambda represents the wavelength. So this condition has to be fulfilled between the transmitting antenna and the receiving antenna. And next what we do here is, after connecting the primary antenna, we are going to disconnect the primary antenna. After disconnecting the primary antenna, we are going to connect the standard gain antenna. The standard gain antenna is aimed towards the transmitting antenna. The transmitting antenna is sending the signal to the standard gain antenna here. And here, what is the amount of power received by the standard gain antenna? We need to record the reading here. And again, we are having the equations, that is based upon the fixed transmission formula. PR is equal to PT GT GR into lambda by 4 pi r whole square. So here, you can see here, when these two are connected, when this secondary antenna is transmitting antenna, this is the transmitting antenna and this is the receiving antenna. So when these two are connected, based upon the fixed transmission formula, we can write the equation what is the amount of power received for this antenna under test by this equation. That is PR2 is equal to P1 G1 G2 into lambda by 4 pi r whole square. Similarly, when we disconnect these two antennas, so when we disconnect this antenna and when we connect these two antennas, now let us assume this has 1, this has 2 and this has 3. So this has 3. When we connect this 1 and 3, what is the amount of power received at this antenna 3 is given by the equation PR3 is equal to P1 G1 G3 into lambda by 4 pi r whole square. So what we did here is 1 and 2 have been connected here. We have written on equation here PR2 is equal to P1 G1 G2 into lambda by 4 pi r whole square. After calculating the power received, so we have disconnected this antenna 2. We have connected this antenna 1 to antenna 3. This 3 is nothing but a standard gain antenna. So what is the amount of power received by the standard gain antenna? So we are writing this fixed transmission formula, that is the amount of power received is equal to P1 G1 G3 into lambda by 4 pi r whole square. Let us find out the ratios of these two antennas. Let us find out the ratios of these two antennas. That is PR2 by PR3 is equal to G2 by G3. So we are going to find out the G3. So G3 is equal to G2 into PR3 by PR2. So we can write from this cross multiplication, G3 is equal to G2 into PR3 by PR2. So G3, it is nothing but the AUT. So G3 is nothing but the AUT. So out of these three antennas, so we are going to find out there are three antennas here. One, this is 3, and this is standard antenna. This is 2. So our intention is to find out the gain of the AUT. Here 3 is AUT. So when 1 and 2 are connected, we are getting this equation. When 1 and 3 are connected, we are getting this equation. Let us find the ratios of these two. We are getting G3 is equal to G2 into PR3 by PR2. So G3 is nothing but GAUT. That is the gain of AUT is given by G reference into PR of AUT by PR of reference. PR of AUT by PR of reference antenna. Here the reference antenna is nothing but the standard gain antenna. That means whose gain is already known. And the PR of AUT we need to calculate. We need to whatever the indicator it has been recorded, that amount of power has to be noted here. In an indicator at the receiving antenna, what is the amount of power recorded, that has to be substituted here. And PR of reference, that means the power received for the reference antenna is already known parameter. So out of these total 4 parameters, 3 parameters are known parameters. So out of these out of these three parameters, so this is a known parameter, and PR reference, this is the known parameter, and PR of AUT we need to perform the experiment, and whatever the amount of power received has to be record the reading, and that recording has to be substituted in the PR of AUT. So after substituting all these values, we need to calculate the amount of G, that is the gain of antenna under test, is given by G ref into PR of AUT by PR of reference. So these are the gain measurement by means of absolute method and direct comparison method. And the next parameter is the directivity. The directivity of antenna is defined as the ratio of maximum power density to the average power radiated. We know that the amount of power density is given as a PD max by Prad, PD max, and average power radiated, that is pi AV. So pi AV is nothing but PR by 4 pi R square. Pi AV is nothing but PR by 4 pi R square. So this is the basic definition of directivity. So from the basic definition of directivity, we can directly calculate this by this formula. There is a PD max by Prad by 4 pi R square. So the directivity of antenna is given by D is equal to GD max. The maximum directive gain is nothing but the directivity. So 4 pi into E max whole square by integration of 0 to 2 pi, integration of 0 to pi, E of theta comma pi whole square into sin theta d theta d pi. And bring this numerator to denominator, you will get E of theta comma pi whole square by E max whole square. Let us assume this total function E of theta comma pi whole square by mod E max whole square as one function f of theta comma pi. So integration of 0 to 2 pi, 0 to pi, this total function let us assume as f of theta comma pi sin theta d pi. So from this definition of directivity, we can write d as 4 pi by f of theta comma pi sin theta d pi. So the drawback of this method is least accuracy in the measurement. This method gives the rough estimates of the directivity, and this method proves to be the best suitable for the antenna whose radiation pattern consists of only one major lobe with negligible minor lobes. So we are going to, why? Because we are going to calculate the directivity by means of a formula, that is the formula is 4 pi of integration of 0 to 2 pi, 0 to pi f of theta comma pi sin theta d pi. So the directivity is directly measured by this formula, d is equal to 4 pi by f of theta comma pi sin theta d pi. So by this method, the accuracy of measuring the directivity is very less by this method. So this is one of the basic disadvantages of directivity measurement by this formula. So with this, we end the session. What we have seen today is how to measure the gain and directivity. So gain is measured by two methods. One is absolute method and direct comparison method. And in absolute method, we are having again two methods. One is two antenna method and the three antenna method. And the gain is also measured by direct comparison method, that is by three antenna method. And also we have seen the measurement of directivity simply by means of a formula, that is the 4 pi by 0 to 2 pi, 0 to pi, f of theta comma pi, sin theta, d theta, d pi. Let us end the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.